Hi, welcome to today's video. Today, we'll be looking at the remove duplicates from sorted list algorithm. We are currently going through the LeetCode patterns by Shem Prashad. The link is in the description. If this is your first time watching our videos, we will encourage you to please subscribe. Let's get into the video. So we are to remove duplicates from sorted lists. So we are told that given the head of a sorted list, we are to delete all duplicates such that each element appears only once. We are to return the linked list sorted as well. So two things are very important. First of all is that it is a sorted, so the word being sorted is important, and then we also to return it sorted. Okay, and we are told that we should make sure that no duplicates, so everything should just be one. So here we have 1 1 2. One of the ones was removed and we just have 1 2. Here we have 1 1 2 2 3, and then we have just one of the ones, one of the two, and one of the three. Okay, two just appeared once, so it's just that. Okay. We are also told that the number of nodes in the list, so we could have an empty list and we could have it up to 300, and the value in our list is between -100 to 100, and we are told that the list is guaranteed. So you see, we are sure that it is sorted in ascending order, so from the smallest to the biggest. We are sure that what is going to be, so we cannot have 1 4 3. No, we are sure that 1, anything 1 will be, then after that 2s, then 3s, and that's in that order. It might not follow sequentially, but we are sure that a bigger number will not appear before a smaller number. Basically, that's what we are being assured of. So let's just put this. So this will be a quick one, I think. It looks quite straightforward. So we have two. Okay, so I think we had a 1, then we had a 3, we have another 3. So since we are guaranteed that this will be, so what I could just do is I could have something. This could be my, of course, this is my head. So I could be checking this and the next. Yes. So what I could just do is I could have my head and I could have, let's say, a next pointer. And what I could just be doing is, if my head, the value in my head is the same with what's in my next, then I remove what is in the next. So for example, I could have my head. So at the beginning, my head is 1 and my next is 1. And I'm asking if my next and head, if they are the same. So what I just want to do is I want to make the next with this, which makes sense. Yes. So this now becomes my next now. So I check again. Is 1, which is my head, equals to 2? No, it's not equals to. So my head, I just move this head to this place, and then my next will move here. So I ask again, is my head, the value in my head, is it equals to the next? No. So this now becomes the head now, and this becomes my next. Okay. So I ask again, is my head, the value in my head is equals to what's in next? Yes. So I now link this. Of course, this is going to be null here. So it means the next here will just be this. So at the end of the day, I will have 1 pointing to 2 pointing to 3. Exactly. So yes, so I think this definitely will solve the problem we're trying to have in this algorithm. So let's just go through that quickly. So we will have, but did the question say we should return the head? Oh yes, we have to return it, so we cannot use head. So let's just have something called current, because we know we need to return our head at the end of the day. Okay, and then we have our, let's call it next, which will be next. So but are we guaranteed that it's not empty? Okay, so it could be empty, so let's just take care of that. So if my head is empty, so I just want to return that it's empty. So if it's not empty, so this is safe to do, because I know that my next will not be, my head is not null. So even if the next is null, that's fine. So we want to check while the current is not equals to null, and my current dot next is not equals to null, because I need to check my value in my in my next also. So basically, okay, that means I don't really need, do I need the next? I don't think I need this then. Or for simplicity's sake, let me just have it here. So we have our next here, and so we could just say if what is in my current, the value, if it's equal to what is in my next, the value, then I know that I have a duplicate. So basically what I just want is the current, the next for my current will now be what is the next of my next. Basically, that's what we have here. And if it is not the same, basically I just want to move my current to the next. My current will be what is in the next now. Okay, and this looks good. So let's just, I'm just feeling like, let me just run it. I'm feeling I'm missing something. Am I? Okay, so this node does not contain current. Oh, my bad. Just so let's see. So okay, so we have a situation where we do not cater for the last item. So why is that? Or so we are checking when we have, so we are not moving. Our next is also supposed to now be current, but next, exactly. I think this makes sense now. So that you know my next, so it keeps checking for the next. Okay, so let's check in. Okay, so not set to reference of an object. So is there any place where we are calling? So at this point, okay, so it's possible that our current is null. Okay, you know, so okay, so we could just have if current is equals to null, we just break out of this. So if my current is null, I break out of this so that it doesn't look for the next on the current. Yes, so I think this makes sense. But if I am going to be doing this, then I think I can change my while loop, since I am saying the current is equals to null. So I'm checking if current is null. But you know, so what I could do, I think if I remove this, how do I, let me just comment that out in case it turns out to not be correct. So if my, while my current is not null, I want to check, so basically the current dot next, and I want to, so this is going to be current. So but you know the problem here will now be, what if the next, so basically I think I just should go with this, because yeah, because at this point, if I want to say the current dot next dot next, the current dot next could also turn out to be null. So I think it's better to have that check here and break out here. I think this makes sense. I think it's fine with me. Let's see. Okay, so let's submit and see. Hopefully we are able to get through this. Okay, so we have a, so we are returning 1 1 instead of returning a 1. So where could that be happening? So we know that our next, we are passing in current dot next as my next. Okay, I think it's because we have current equals to null and we are breaking out of that. So what we could do, because you know initially this is my head, my current, and this is my next, and then when my next moves, when my current, we see this is this, and we make this to be the next, so we are left with just 1 1. So at that point my next is going to be null. Okay, so I think I'm not supposed to move my current. Okay, so it means most likely I'm not supposed to move my current. So else, so if it is the same value, so for example, if my current of val, if I have the same value and I move this to this, my current should still remain. Yeah. So my current should not change. Else, then the current should change. And if the current changes, okay. So let's try this now. Okay, so that does it for us. So let's just check it again. So basically, what we did here was we just checked if our current is not null and if the next item also is not null, because we are going to check, we are going to get the value of what is in our next. So if that turns out to be null, then we have a problem there. So that's why we have a check for our next and for the current. And the next is just our head. The initial point is going to be the next point from our head. So, but what we are doing here is that if it is equal, then we do not want to move our current because we still want to compare. So, for example, in this case, when we have one here and we have the second one here, when we remove this one, we do not want to, we want to make sure that we are still comparing this first one with these two. That's what we want to ensure. So we don't move our current in that situation. We only move it if they are not equal. That is why it's only our current only moves when they are not equal. And that is how we have our solution. So if you enjoyed this video, please like, share, and subscribe. I actually like that we have this little challenge here. At least it shows how I kind of think about my problems when I'm trying to solve them, and I hope it was helpful for you too. Thank you, and see you in the next video.